So just a quick video, again, just an update on where things are at. So I've had some setbacks, but I'll explain that shortly. So for the display, I still haven't done anything for the top yet. I finally have the 3D bracket printed up, and that's with a little standoff in there. I still got to print this standoff because this is a really hard distance to measure with this curved angle. There's actually two curves in there. There's like about a 25 or 30 millimeter curve on this one, and then like a 150 millimeter radius on this one. And it's like it just wasn't fun to kind of model up. But I'm happy with the back plate, and the connector is accessible and everything, and it will be nice and solid when this final bracket gets made. So that's that. Now my setback was the main controller board. So the main controller board had this Neoton eval kit that got plugged into it. So this has two DC-DC switchers that take the 48 volt battery and down convert it to 12 and 5 volts for use on the processor and for driving the LED lamps and the horn and whatever else is going to run off of 12 volts. Now my big problem is that I got the pinout wrong, and the pinout, because I was being cheap and I was trying to reuse parts I had, I didn't have this connector is actually not the pin count of what the header is, so there had to be no connect pins, and that messed up the pin ordering that I had put in. And so when I went to plug in my board and did a check, and impedance check on the rails, I found out it was shorted out, and then going back and checking, finding out that the pinout was wrong kind of was frustrating. So this board is not a throwaway. If I make another board that has just this on it with this pinout, I can use it, but it's still quite annoying because it took quite a long time to actually solder it up, test it. The milling was painful. Anyways, so then my fun began. So I started off with the first try, and Windows 10 decided to do an update, and that trashed that one. And then the second try. So the second try worked, but it cut too deep, and I had 10 mil traces on there that were more like a couple mil wide after the milling operation. So I could have lived with that. I could still use the board. However, I made an adjustment to some ceramic capacitor footprints that turned out to be wrong. So this ended up being kind of like a throwaway board, unfortunately. So this past weekend, I actually milled up the last one. Now, the last one actually didn't do too bad for the actual trace widths, and everything looks good. I'm gonna have to go through and do a check cleanup, or a quick cleanup of the gaps in between the traces and the voided copper, just to make sure there's no shorts. Because what I do with my boards is that I run all my traces, and then I flood both top and bottom with ground. So for the most part, that covers all the ground connections, and with the vias in the right places, you're always guaranteed to have everything connected. I did find a few little quirks that I missed. With two-layer board, you have to be really careful to make sure that you have access to the pin side of a connector for soldering, and that all your connections are made from that side of it, because you cannot get access to underneath the connector to solder to underneath the part itself. So I think I had a couple of places where that had happened, and because I'd left on the replace etch when I was routing some of the traces. So that means that when you route your trace on the bottom, if there's a connection on the top, it'll remove that connection, or vice versa. So that was kind of annoying, but again, that's a jumper wire. Now I'm going to be populating this sometime this week, and I had to wait for the new headers to come in, like the receptacles for the 100th thou headers. So these guys here. So I have them now. I can now start to begin to populate the board. I might have to strip another donor e-waste board to get some ceramics, because these ceramics, they're actually very expensive. Like they're 10 microfarad 100 volt X5S, I think, capacitors. So their voltage capacitance effects bring it down to more like somewhere around four and change for microfarads of capacitance, because with ceramics you lose a lot of capacitance unless you're an MPO type dielectric. You lose a lot of your capacitance with voltage applied, so the DC bias affects that. So if you're ever using the ceramics, just be careful about that and read the spec sheets on them. So the other thing that I did was I made up a new push button switch. I was looking for one that had momentary switches only, but a lot of these motorcycle scooter style button arrays for the handlebars usually have an actual on-off switch that's toggle, and then you have a momentary for the horn. And because I have a main controller that actually decides what gets on, what gets off or turned off, I don't want to be latching any light on manually. So I just want to say, you know, turn on the light or hit the horn, or, you know, remove the speed governor so I can go really fast and you know, hurt myself. But I don't want to latch that in. So I don't really like what I did here, because it sits on the handlebar kind of like this. So if it's on the left side, I would like to come up with something a little more imaginative, but I only had this bracket, extra bracket hanging around, and I didn't want to make this out of PLA. PLA is a very brittle plastic, and this is made out of PLA, but it's not seeing any major stress. And this here will see bending, and I'm not sure what the material is, but it's a fairly tough plastic, and I'm not worried about breaking it. This will probably break before this will. Anyways, so that's that. And probably after this this board is populated and tested, the next thing will be to do the rear plastic carrier for it, so that it can be screwed to the bottom of the head assembly. So there's 3 screws in the bottom of the head assembly that will allow me to bolt a carrier plate in there, the plastic carrier plate, and then have the main controller in there. And once it's in, then we can start assembling the head, and you know, also start thinking about how to do the analog brakes. I'm not still sure about how to approach that one. It may be short term. I'll just stick with the switch and be done with it until I have more time later on to come up with a more ingenious way of doing a reasonably ranged brake lever. So that's it for now. I'm going to probably be changing my titles to be parts instead of weeks, since you know, it's no longer on a weekly basis that things are getting done. But you know, I hope to improve that a little bit as I go on. Thanks for watching.